Let's peel back the cover on the tools and tech that shape our world. Ready for a deep dive? This channel is your backstage pass into the fascinating universe of big machines, smart products, and next-level tools. We break down the mechanics behind everything from industrial robots and circuit boards to power tools and DIY repairs. Curious about how things work, how they're made, or even how to fix them. When we think about making electricity, we often picture giant power plants burning coal or natural gas. Or maybe we think of wind turbines spinning on a hill or solar panels on a roof. These are important, but there is another source of clean energy that is often overlooked. It is all around us every single day. I am talking about waste, specifically organic waste. This includes things like food scraps from our kitchens, manure from farms, and even sewage from our cities. All of this material, which we usually just throw away or let rot, holds a surprising amount of trapped energy. This energy can be unlocked and turned into something called biogas. Think of biogas as a natural gas that we can make ourselves, instead of drilling for it deep underground. The process that creates it is completely natural. It is the same process that happens in a swamp or at the bottom of a lake. Tiny organisms, called microbes, get to work breaking down the organic material. As they eat away at the waste, they release a mixture of gases. This mixture is what we call biogas, and it is a powerful source of fuel that can be harnessed for our energy needs. This is not a new or futuristic idea. People have been using similar processes for centuries to manage waste. What is new is our ability to do it on a large scale, efficiently and safely, to generate reliable electricity. The science is straightforward. The main ingredient in biogas is methane, which is the same gas that makes up most of the natural gas we use for heating and cooking. By capturing this methane from decomposing waste, we are not only creating a valuable fuel source, but we are also preventing a potent greenhouse gas from escaping into the atmosphere where it would contribute to climate change. So, instead of seeing a pile of cow manure or a bin of leftover food as just garbage, we can start to see it as a potential power source. It is about changing our perspective on what we consider waste. This is a crucial step in building a world with zero carbon emissions. We need to get clever and use every tool available to us. Turning our unavoidable organic waste into clean electricity is one of the most practical and effective tools we have. It is an opportunity hiding in plain sight, waiting for us to put it to good use in our fight against climate change. So how do we get from a pile of organic waste to electricity that can power our homes? The process happens inside a large sealed container called an anaerobic digester. The term anaerobic simply means without oxygen. This is the key to the whole process. Inside this tank, we create the perfect environment for specific types of microbes to thrive. These are the microbes that break down organic material and produce biogas. We feed the digester a steady diet of waste, like food scraps, agricultural residues, or wastewater sludge, creating a kind of soup for the microbes to feast on. Once the waste is inside the sealed digester, the microbes get to work. It is like a microscopic factory. In the absence of oxygen, these tiny organisms begin to decompose the complex organic matter. They break down the carbohydrates, proteins, and fats into simpler compounds. As they do this, they release a mixture of gases. This gas mixture, or biogas, is mostly methane, around 50 to 75%, and carbon dioxide, with small amounts of other gases. The digester is designed to capture all of this gas as it is produced, preventing it from escaping. After the gas is collected, it needs a little bit of cleaning. This step is called upgrading or purification. The goal is to remove impurities like carbon dioxide, water vapor, and hydrogen sulfide. Removing these components increases the concentration of methane, making the gas a more potent and efficient fuel. Once the biogas is cleaned, it is essentially the same as the natural gas we get from fossil fuels. It is ready to be used to generate power. This purified biogas is often called biomethane because of its high methane content and biological origin. The final step is turning this gas into electricity. The cleaned biogas is piped to a special type of engine or turbine. This is very similar to the engines found in typical gas-fired power plants. The biogas is burned as fuel, and the heat from this combustion is used to turn a turbine. The spinning turbine then drives a generator, and the generator produces electricity. This electricity can then be fed directly into the local power grid, ready to be used by homes, schools, and businesses. It is a complete cycle, transforming something we would throw away into a valuable, essential resource. The benefits of using biogas to generate electricity are significant, and they extend far beyond just keeping the lights on. The most important benefit is for our environment. When organic waste rots in a landfill, it releases methane directly into the atmosphere. Methane is a greenhouse gas that is over 25 times more potent than carbon dioxide at trapping heat over a 100-year period. By capturing this waste and putting it in a digester, we are trapping that methane. We then burn it to create electricity, which converts the potent methane into carbon dioxide and water, a much less harmful outcome for the climate. This process also creates a valuable byproduct. After the microbes have produced all the biogas they can, the material left over in the digester is a nutrient-rich substance called digestate. This material makes an excellent organic fertilizer. Farmers can spread it on their fields to improve soil health and help their crops grow. This reduces the need for synthetic, fossil fuel-based fertilizers, which require a lot of energy to produce and can have their own negative environmental impacts. It is a perfect example of a circular economy, where the waste from one process becomes a valuable input for another. From an economic standpoint, biogas power offers a new revenue stream for farms and municipalities. A farmer can turn animal manure, which is often a costly disposal problem, into two valuable products: electricity to sell to the grid and fertilizer to use on their own land. For cities, using the organic material from wastewater treatment plants to generate power can lower the plant's operating costs and reduce its reliance on the grid. This makes our communities more resilient and self-sufficient, which is a major advantage in an uncertain world. It creates local jobs and keeps energy dollars in the local economy. Furthermore, biogas provides a reliable and consistent source of clean energy. Unlike solar and wind, which depend on the weather, a biogas plant can run 24 hours a day, 7 days a week, as long as it has a steady supply of organic waste. This is called baseload power, and it is critical for keeping our power grid stable. Having a dependable source of renewable energy that can fill the gaps when the sun is not shining or the wind is not blowing is essential for a successful transition to a zero-carbon energy system. Biogas fits this role perfectly. As we work toward a future powered by clean energy, it is clear that there is no single silver bullet solution. We are going to need a wide range of technologies working together. We need breakthroughs in solar, wind, nuclear, and energy storage. And among these critical tools, biogas power has earned its place as a key piece of the puzzle. It addresses several problems at once. It reduces potent greenhouse gas emissions, it effectively manages our waste, and it produces reliable, carbon-neutral electricity. It is a technology that is practical, proven, and ready to be deployed more widely today. The beauty of biogas lies in its ability to turn a liability into an asset. Every community in the world produces organic waste, from large agricultural operations to individual households. This means that the potential to generate biogas exists everywhere. It is a decentralized energy solution that can be scaled to fit the needs of a small farm or a large city. This local approach to energy production strengthens our communities, reduces our dependence on complex global supply chains for fossil fuels, and makes our energy system more robust and resilient against disruptions. Of course, like any technology, we need to continue innovating to make biogas systems more efficient and cost-effective. We need policies that encourage the separation of organic waste and support the development of biogas facilities. We need to invest in research to find new types of microbes that can break down tougher materials or produce gas more quickly. But the fundamental concept is sound, and the path forward is clear. We must get better at recognizing the value in things we currently discard and build the systems needed to capture that value. In the grand challenge of avoiding a climate disaster, we cannot afford to leave any good options off the table. Biogas is a fantastic example of a solution that closes the loop, turning a potential pollutant into a powerful resource. It helps us clean up our farms and cities while also cleaning up our power supply. By embracing technologies like biogas, we are not just choosing a different way to make electricity. We are choosing to build a smarter, cleaner, and more sustainable world for everyone. It is a practical step we can and should be taking right now.